Welcome back to our channel, viewers. Now look at this radical geometry problem. You've been told to determine the red area. How do we determine the red area? Now in this geometry problem, it is composed of a rectangle and a semicircle and a right-angled triangle. Now if we divide it in this manner, we can label this diagram. We can let this to be point A, point B, maybe that is point C, point D, point E, point F, point G, point H, and the center of the semicircle point O. Maybe you can let that to be point X. Now this is extremely simple. If you look at this diagram, you've been given a right-angled triangle. This right-angled triangle, we said it is triangle. You can let this is point Y. So triangle YBC. So this right-angled triangle, triangle YBC, you can actually use Pythagoras theorem to get the hypotenuse YC. So hypotenuse, if you let that to be small c, small b, small a and small b, then according to Pythagoras theorem, then c squared is equals to a squared plus b squared. So that implies that c squared is equals to a, we've been told from b to c is 24, that is going to be 24 squared plus b is from y to b, which is 10. So 24 squared plus 10 squared. So for you to get c, you simply look for the square root on both sides. So the square root of 24 squared plus 10 squared is 26. So it means the length from y to c is 26. So if you come back here, the length from y to c is 26. So if this length is 26 and O is the center of this semicircle, then it means that 26 is divided into two equal parts. And when it is divided into two equal parts, it is divided into 13 by 13. Now from there, you've now known the radius of the semicircle. From the center to any point at the circumference is always the radius. So it means if from O to Y is 13, from O to this point C is 13, then it means from O to F is also 13, because it is from the center of the semicircle to the circumference. Again, from O to G is also 13, because it is from the center of the semicircle to the circumference. Now, if we let this height from O to X to be small h, then we can actually use congruence to determine the value of small h. Because you can see triangle CYB is congruent to triangle OYX. So triangle CYB is actually congruent to triangle OYX. So if you compare the heights, you start with the height small h over the big H, which is 24, is equals to smaller hypotenuse, which is from O to Y, which is 13, over the bigger hypotenuse, which is from Y to C. 13 plus 13, 20, 26. So what is H? For you to get H, you simply multiply both sides by 24. 24 goes with 24. You remain with H to be equals to 13 goes here once, 13 goes here 2. So 24 over 2, you get H to be 12. So it means the length from O to X is 12. So if from O to X is 12, then automatically from H to Y is also 12. Because you can see this YXOH is a rectangle. Now again, if you take triangle OHY, that is a right angle triangle at point H. So you can actually determine this length HO using Pythagoras theorem. If you take triangle OHY, so triangle OHY is a right angle triangle. So according to Pythagoras theorem, for you to get O to H, so for you to get from O to H, then you will have OH squared plus HY squared is equals to the hypotenuse square OY squared. So if you substitute, we have OH squared to be equals to OY squared from O to Y is 13. That is going to be 13 squared. Then HY squared is going to be now minus 12 squared, because HY squared was on this side. When you take it on the other side of the equation, it becomes minus. Now for you to get OH, you simply look for the square root on both sides. So if you look for the square root, you get OH squared root 13 squared minus 12 squared is square root of 25, which is 5. So it means the length from O to H is 5. Now, if the length from O to H is 5 and the length from O to the circumference is 13, then automatically the length from H to G is 13 minus 5, which is 8. So it means the length from Y to A is 8 because GHYA is a rectangle. So from this, we can now see again, it therefore means from G to O is 13, meaning from E to F is 13. And if the width or the length is from A to B, which is 8 plus 10, that is 8 plus 10 is 18. So if 8 plus 10 is 18 and from E to F is 13, meaning from F to D is 5, because that length has to be 18, as we've seen from A to B, which is 8 plus 10. Ladies and gentlemen, we've determined all the unknown values. Now our case is now very simple to determine the red area. How do we now determine the red area? So to get the red area, we'll take the area of the whole rectangle ABDE, which is given to be, so the area of rectangle ABDE is going to be length times width, which is the length is from E to D, which is 13 plus 5, that is 18, times the width is from A to E. So remember, from A to G we found is 12, then from G to E is 13, from Y to H is 12, meaning from A to G is 12, then from O to F is 13, meaning from G to E is also 13. So it means the width is from A to E, which is 13, which is 12 plus 13, that is 25. So we have 18 times 25, 450. So we have the area of the whole of this rectangle to be 450. Then we now remove the area of this triangle. The area of this triangle is triangle YBC. So triangle YBC, the area of a triangle, a right angle triangle, is a half base times height. The base is from Y to B, which is 10. So it is a half times 10. Then the height is from B to C, which is 20, which is 24. So a half times 10 times 24, a half of 24 is 12 times 10, that is 120. What is now left is the area of the semicircle. Area of the circle is going to be pi r squared, is the area of the circle. Then we now talk of the semicircle, we divide it by 2. So the area of the semicircle is pi r squared over 2, which is going to be pi times the radius of the semicircle. We have the radius of the semicircle we found is 13. So it is pi into 13 squared over 2. Ladies and gentlemen, how do we now determine the red area? Now the red area is very simple. It is the area of the whole rectangle ABDE, which we found to be 450. Then it is minus the area of the triangle plus the area of the semicircle. So the area of the triangle is 120 plus the area of the semicircle is pi 13 squared over 2. Pi 13 squared over 2. Ladies and gentlemen, that is the red area. And if you work out that mathematics, you are supposed to get approximately 64.53 units square. That is the simplest means to solve this radical Olympiad geometry problem. If you have any other simpler method, you can leave it in the comment section. Thank you for joining our live lesson and see you again in our next presentation.